Welcome. Today we're diving into the fascinating world of probability. Probability is all about measuring the likelihood of events happening. Whether you're rolling dice, drawing cards, or predicting the weather, probability helps us make sense of uncertainty. In this video, we'll break down the essential rules of probability, making them easy to understand and apply. By the end, you'll have a solid grasp of the basics and be ready to tackle more complex problems. Let's start by exploring what probability really means and why it's so important in our daily lives. Probability is a measure of how likely an event is to occur. It's usually expressed as a number between 0 and 1, where 0 means impossible and 1 means certain. For example, the probability of flipping a fair coin and getting heads is 0.5. This simple idea forms the foundation for all probability rules. Understanding this basic definition helps us analyze situations, make predictions, and solve problems in a logical way. Let's look at how we calculate probability in different scenarios. Basic formula for probability is straightforward. Probability equals the number of favorable outcomes divided by the total number of possible outcomes. For instance, if you have a bag with 3 red balls and 2 blue balls, the probability of picking a red ball is 3 out of 5 or 0.6. This formula is the starting point for solving many probability problems, and it's essential to always count outcomes carefully. Next, we'll see how this formula applies to different types of events. Some events are guaranteed to happen, while others are impossible. For example, the probability of rolling a number between 1 and 6 on a standard die is 1 because it's certain. On the other hand, rolling a 7 is impossible, so the probability is 0. Recognizing these extremes helps us understand the range of probability values and set the stage for more nuanced cases. Let's move on to events that fall somewhere in between. Simple event is an outcome that cannot be broken down any further. For example, drawing a single card from a deck and getting the ace of spades is a simple event. Each simple event has its own probability, and all the probabilities of simple events in a sample space add up to 1. This concept is crucial for understanding how probability is distributed across all possible outcomes. Next, we'll see how to handle more complex situations. Compound events involve 2 or more simple events. For example, drawing 2 cards from a deck or rolling 2 dice. The probability of a compound event depends on whether the events are independent or dependent. We'll explore these differences soon, but for now, remember that compound events require us to consider combinations and sequences of outcomes. This adds a layer of complexity, but the basic rules still apply. Addition rule helps us find the probability that at least one of several events occurs. If 2 events cannot happen at the same time, they are called mutually exclusive. For mutually exclusive events, simply add their probabilities. For example, the probability of drawing a heart or a spade from a deck is the probability of a heart plus the probability of a spade. This rule is very useful in many practical situations. Sometimes events can overlap. For example, drawing a red card or a king from a deck, some cards are both red and kings. In these cases, we use the general addition rule, add the probabilities of each event, then subtract the probability of both events happening together. This prevents double counting the overlap. Understanding this distinction is key to solving more advanced probability problems. Multiplication rule is used to find the probability that 2 or more independent events all occur. For instance, the probability of flipping 2 coins and both landing heads is the probability of heads on the first coin times the probability of heads on the second coin. This rule is essential when dealing with sequences of independent events. Let's see how it works in practice. Sometimes the outcome of one event affects the probability of another. These are called dependent events. For example, if you draw a card from a deck and don't put it back, the probability of drawing a second card changes. In such cases, you multiply the probability of the first event by the probability of the second event, given the first has already happened. This adjustment is crucial for accurate calculation. Every event has a complement, the event that it does not happen. For example, if the probability of rain tomorrow is 0.3, the probability that it won't rain is 1 minus 0.3 or 0.7. Complementary events always add up to 1. This rule is handy when it's easier to calculate the probability of the complement and then subtract from 1 to find the answer you need. Additional probability is the probability of one event occurring given that another event has already happened. For example, if you know a card drawn is red, what's the probability it's a heart? This concept is vital in many real-world situations like medical testing or risk assessment. The formula for conditional probability helps us update our predictions based on new information. Dependent events are those where the outcome of one does not affect the other. Tossing a coin and rolling a die are independent. What happens with the coin doesn't change the die's outcome. Recognizing independence is important because it determines which probability rules to use. We'll see more examples of independent events as we go along. Mutually exclusive events cannot happen at the same time. For example, when rolling a die, getting a 2 and getting a 5 are mutually exclusive. You can't get both on a single roll. This property simplifies calculations as the probability of either event happening is just the sum of their individual probabilities. Non-mutually exclusive events can occur together. For example, drawing a queen or a heart from a deck, some cards are both. In these cases, remember to subtract the overlap to avoid counting it twice. This distinction is crucial for accurate probability calculations and helps prevent common mistakes. Sample space is the set of all possible outcomes of an experiment. For example, when tossing a coin, the sample space is heads and tails. Listing the sample space helps ensure you consider every possible outcome, which is essential for accurate probability calculations. It's a fundamental concept that underpins all probability work. An event is any collection of outcomes from the sample space. For example, rolling an even number on a die is an event that includes 2, 4, and 6. Understanding the difference between events and outcomes helps you organize your thinking and apply the correct probability rules. When all outcomes in a sample space are equally likely, calculating probability is straightforward. For example, each side of a fair die has an equal chance of landing face-up. This assumption is common in many basic probability problems and makes calculations much simpler. Probability values range from 0 to 1. A probability of 0 means impossible, 1 means cert, and values in between represent varying degrees of likelihood. Visualizing probability on a scale helps you compare different events and understand their chances of occurring. The law of large numbers states that as you repeat an experiment many times, the experimental probability approaches the theoretical probability. For example, if you flip a coin thousands of times, the proportion of heads will get closer to 0.5. This law explains why probability is reliable over the long run. Theoretical probability is based on known possible outcomes, while experimental probability is based on actual results from trials. For example, theoretically, a coin has a 0.5 chance of heads, but in 10 flips you might get 7 heads. Over many trials, experimental results tend to match theoretical predictions. Tree diagrams are a helpful way to visualize all possible outcomes of a sequence of events. Each branch represents a possible outcome, making it easier to calculate probabilities for compound events. Tree diagrams are especially useful for organizing complex problems involving multiple steps. Venn diagrams use circles to show relationships between different events. They're great for visualizing overlaps, such as events that are not mutually exclusive. By shading different regions, you can see how probabilities combine and where overlaps occur. Probability tables organize information about possible outcomes and their probabilities. They're especially useful for games, dice, or cards where you need to keep track of many possibilities. Tables make it easier to spot patterns and calculate combined probabilities. Odds and probability are related but different. Probability measures the chance of an event happening, while odds compare the chance of it happening to not happening. For example, if the probability is 0.25, the odds are 1 to 3. Understanding the difference helps you interpret results correctly. Let's apply the complement rule. Suppose the probability of drawing a red card from a deck is 0.5. The probability of not drawing a red card is 1 minus 0.5, or 0.5. This simple calculation is often the quickest way to solve problems, especially when the complement is easier to find. Probability isn't just for games or math class. It's used in weather forecasts, insurance, medicine, and even sports. Understanding probability helps you make better decisions, assess risks, and interpret statistics you encounter every day. It's easy to make mistakes in probability, like forgetting to subtract overlaps or assuming events are independent when they're not. Always double-check your calculations and make sure you're using the right rules for the situation. Careful thinking leads to accurate results. Games of chance like dice, cards, and lotteries are classic examples of probability in action. Understanding the rules of probability can give you an edge, whether you're playing for fun or analyzing strategies. It's all about knowing the odds and making informed choices. Probability is the foundation of statistics. While probability predicts what should happen, statistics analyzes what actually happens. Together, they help us make sense of data, draw conclusions, and make predictions in science, business, and everyday life. A random variable is a variable whose value depends on the outcome of a random event. For example, the number of heads in 3 coin tosses is a random variable. Understanding random variables is key to working with probability distributions and more advanced topics. Probability can be discrete or continuous. Discrete probability deals with countable outcomes like rolling dice. Continuous probability deals with ranges of values like measuring the time it takes for an event to happen. Knowing the difference helps you choose the right tools for each problem. A probability distribution shows how probabilities are spread across possible values of a random variable. For example, the distribution of sums when rolling 2 dice. Distributions are fundamental for understanding patterns and making predictions. The expected value is the average outcome you'd expect if you repeated an experiment many times. It's calculated by multiplying each outcome by its probability and adding them up. Expected value is a powerful tool for making decisions under uncertainty. Variance and standard deviation measure how spread out the outcomes are from the expected value. High variance means outcomes are more spread out, while low variance means they're closer to the average. These measures help you understand risk and uncertainty. Let's see how probability trees help solve real problems. Suppose you flip a coin and then roll a die. A tree diagram helps you list all possible outcomes and calculate the probability of each. This visual approach makes complex problems much easier to handle. Bayes' theorem is a powerful rule for updating probabilities based on new information. It's widely used in science, medicine, and artificial intelligence. The theorem helps you revise your predictions as you gather more data, making your conclusions more accurate. Simulations use computers to model random events and estimate probabilities. For example, you can simulate thousands of dice rolls to see how often certain outcomes occur. Simulations are especially useful when calculations are too complex to do by hand. Probability helps us make better decisions by weighing risks and rewards. Whether you're investing money, planning a trip, or choosing a strategy in a game, understanding probability allows you to make choices based on logic and evidence, not just guesswork. Risk is all about uncertainty, and probability is the tool we use to measure and manage it. From insurance to engineering, professionals use probability to assess risks and make informed decisions. Knowing the rules of probability is essential for understanding and controlling risk. Scientists use probability to interpret experiments, analyze data, and make predictions. From genetics to physics, probability helps researchers understand patterns and draw reliable conclusions. Mastering probability is a key skill for anyone interested in science. Businesses use probability to forecast sales, manage inventory, and assess risks. By applying probability rules, companies can make smarter decisions and improve their chances of success. Probability is a powerful tool in the world of business and finance. Let's quickly review the key rules of probability: the addition rule, multiplication rule, complement rule, and conditional probability. Each rule has its place, and knowing when to use each one is the secret to solving probability problems efficiently and accurately. The best way to master probability is through practice. Try solving different types of problems from simple to complex. The more you practice, the more confident you'll become in applying the rules and tackling new challenges. Congratulations, you've learned the fundamental rules of probability and how to apply them. These concepts are the building blocks for more advanced topics in statistics and data science. Keep exploring, keep practicing, and you'll find probability is not just useful but also fascinating.